5.3, we were using proportions to find the geometric mean. Okay, we're going to continue working with proportions all this unit. We're going back to what we talked about. We're kind of reviewing what we talked about before Thanksgiving break. In 5.2, we discussed similar figures. So what we're going to be doing today is finding missing side lengths in similar figures. So if you want to add that here in similar figures, you can. And if you need to refer to your notes from 5.2 later, when you're doing your practice, that's where we talked about what similar figures are. And we said that similar figures have congruent angles. The corresponding angles are the same, and the corresponding sides are proportional. So that's what we're going to use here, is we're going to use proportions. So finding side lengths using proportions. Okay, so I'm going to write out here on the left the steps that we're going to do, and then we're going to do them as I talk about them. So the first thing we always want to do is mark or label somehow, whether it's color coding with highlighters or putting shapes on them or arcs on the angles, however you want to do it. You want to mark your corresponding parts. And I'm going to say parts instead of sides or angles because you can do both. So the corresponding parts. So in number 1, for example, these two are drawn in the same orientation, meaning they're drawn at the same angle. They haven't been rotated or reflected or anything like that. They're just side by side. It's just one is a dilation of the other. This one's just enlarged. Does that make sense? So these are, it tells you that they are similar. Okay, so that means the sides that correspond are easy to see when they're drawn on the same orientation. The top corresponds to the top. The left corresponds to the left. So we mark somehow which ones correspond to each other. Okay, I'm doing highlighting. If you don't have a highlighter or colored pens or something, you could put little shapes on them. You could say, okay, triangle to triangle, circle to circle, something like that. I don't care how you mark it, but you need to mark it somehow on which ones correspond to each other. Okay, so then the next step, once you know what corresponds, you're going to set up a proportion. Remember, a proportion is one ratio equal to another. Okay, so they've already got the lines for the fractions drawn and the equal sign. So we need some numerator over denominator equal to another numerator over denominator. Okay, so there's only 4 pieces marked in this picture. Now, when you're setting up your proportion, I'm going to add here, be consistent. Because if you're not consistent, you won't get the right proportion set up. So I could go green to green, blue to blue. But if I go 14 to 21, if I say 14 is to 21, I went left to right, didn't I? Left to right. So I have to go left to right. That's what I mean when I say be consistent. Okay, I went green to green, left to right. I can't now go blue to blue and go x over 42 because that's going the wrong direction. So if I do 14 is to 21 as 42 is to x. That is not the only correct proportion. Okay, I'm going to put some others here along the side, other ways you could have done this. Instead of going left to right with corresponding parts, you could have flipped that. You could have gone right to left. You could have said 21 over 14 and x over 42. So you could simply flip both of those. Or you could stay on the left quadrilateral and you could go blue to green and then go blue to green. So I could do 42 is to 14. And I have to be consistent. I went blue to green in the small image, and then I have to go blue to green in the big image. So that would be x is to 21. And I could flip both of those. I could go 14 to 42, 21 to X. Okay, so I've already talked about 4 different ways you could set this up. And you're going to be solving the proportion the same way. And that's the last step, is to solve the proportion. And we do that by cross multiplying. So you cross multiply to solve. Okay, so up here, when I go to cross multiply, that's 21 by 42. And that's 14 times X. Now, some of you won't write that line that I just wrote. You'll jump straight to going ahead and multiplying those. So 21 by 42 is 882. So if you go 882 equals 14x, then what would you do to get rid of the 14? You're going to divide, because that's the opposite operation. So what you do to one side, you do to the other. So that gets x by itself, and 882 divided by 14 is 63. And then I read the question and double check that I've answered what they asked. They said, find the value of x. That's what I found. So I am good. I found the correct thing. And I want you to see, if I had set it up differently like this one, aren't I still multiplying 42 and 21? And then dividing by the 14? That's why there's more than one way that you can set this up, because when you cross multiply, you end up doing the same math. You end up multiplying by the same values and dividing by the third, as long as you have it set up in one of the correct ways. Okay, now in Desmos, I want you to see something. In Desmos, you can check your answers. So if I got 60, I said that this is proportional, so I could double check that I solved correctly. I could say, okay, 14 is to 21 as, and then it's 42 is, and then we got 63. So let's check and see if that comes out the same. Did it come out the same? 2/3 and 2/3, right? So yes, if x is 63, these are equivalent ratios. So that is correct. So you can check your answers in Desmos. So I'm going to add that down here. Check in Desmos. Okay, so that's the same process we're going to follow, those steps for all of these. Okay, I'm going to move a little bit faster. Okay, so in number 2, I'm going to mark my corresponding sides. Now this one's a little tougher because this triangle is not drawn in the same orientation as the left one, is it? It's been turned. Somebody rotated it so that that point is now at the bottom that was at the top. Do y'all see that? Okay, so you have to check here. Looking at this, I can see that X is the longest side of the left triangle, and this is the longest side. So those correspond to each other. Okay, and then you can see the medium side to the medium side, and then the short side to the short side. Yeah, follow? So I've marked my corresponding parts. Okay, do shapes if you don't have colors. Now I'm going to set up my proportion. I'm not using the yellow sides. Neither of the yellow sides are marked. So I'm going to use the pink and the blue. So I could go pink, pink, blue, blue, or pink, blue, pink, blue, or blue, pink, blue, pink. It doesn't matter as long as I'm consistent. Okay, so somebody give me the first ratio you want to use. What to what? How do we want to start this one? Any idea on how to set it up? 28 to X. Okay, so I'm going pink on the right to pink on the left. Okay, so I can do that. 28 is to X. So if I went pink on the right to pink on the left, now I have to go blue on the right to blue on the left, or blue from the small to blue in the big. So 25 to 30. That works. That is one correct way to set up the proportion. Okay, now I have my proportion set up. I'm going to cross multiply. Okay, so I'm going to do the 25x and 28 times 30 is 840. And then I end up dividing out that 25. So 840 divided by 25 is 33.6. And I would take this and I would go plug it into Desmos and check that those proportions that proportion is true, that those ratios are equivalent. And I'm going to save you time and tell you it does check out. I already showed you how to check it in Desmos. This one does check out. That's correct. Okay, now as you get the hang of this, y'all are going to probably start showing less and less work. Like over here, I showed exactly what I was multiplying. And this one, I didn't show that line. I went straight here. But once you realize you're just multiplying the two that are diagonal and dividing by the third, y'all are going to show even less work. Okay, so in this next one, I'm going to mark my corresponding parts. So my, let's see. Now this one is harder to tell. They're definitely not in the same orientation. However, they told me up here what the similarity statement is. We talked about similarity statements in our 5.2 notes as well. And we said that the order matters. So since A is first and D is first, that means A and D are congruent. So I can mark A and D congruent. And since B is in the middle and E is in the middle, I know B and E are congruent. And then you can mark the third one or you can leave it unmarked because it's still the same. Does that make sense? So these are the corresponding angles. And then if you still want to highlight corresponding sides, you can. So the 2 arcs to no arcs, 2 arcs to no arcs. Okay, 1 to 2, 1 to 2. So those are the corresponding sides that are labeled here that I'm going to use to set up my proportion. So when I set up my proportion, I'm going to go X is to 28. So I'm going on the left triangle, pink to green. So now in the right triangle, I have to go what to what? Pink to green, which is 25 to 20. If you put 20 over 25, you're going to get it wrong since we did X over 28. You have to be consistent. That's why it's important to mark those corresponding sides. Now here's what I mean. You know that the two diagonal are going to get multiplied and you're going to divide by the third. So a lot of y'all are going to come straight to do that and you're just going to put in your calculator 28 times 25 divided by 20. And you're going to do it all in one step once you get the hang of this. And that's great. That works. So that comes out to 35. And again, they asked for the value of X, so that's my answer. I don't have to go plug it in or do anything with it. I would go to Desmos and check 35 over 28 and 25 over 20, and I would see those are the same. Those reduce to the same ratio. They're equivalent. All right, so same idea here. They've told me my similarity statement for these quadrilaterals. It says P is first and W is first. So that means P and W are congruent. Q and X. R and Y. And then S to Z. And I'm just going to leave those blank because they still match. Okay, now looking at what's labeled in my picture, what I'm going to be looking for, okay, I'm looking for X, which is the no marked angle to 3 arcs. So no arc to 3 arcs. That's the 32 over there. So those correspond. And then Z, oops, that's supposed to switch colors. ZW, that's no arc to one arc, no arc to one arc, would correspond to the 75. Okay, so now I'm going to set up my proportion, and I could do X is to 32 and go left to right, yellow, and then I'd have to go left to right, blue. So 75 to 40. I also want to make sure y'all are thinking logically. If you have a multiple choice question, for instance, which some of your test or quiz questions will be multiple choice, and you're looking for a side, I really hope you'll eliminate some ones that don't make sense logically. Because do you see how this shape is bigger? This is the larger one than this one, isn't it? You can see 75 is bigger than 40. So we know X has to be bigger than what? It has to be more than 32. Okay, and you can see 75 is not double 40, it's less than double. So I know it's not going to be double 32, it's going to be less than 64, but I know it's got to be somewhere between 32 and 64. So oftentimes, if you just think logically, you can eliminate some answer choices that don't even make sense. Okay, so I just want you to make sure that you keep that in the back of your mind. Okay, so now when I go to solve this one, I'm multiplying the 32 and the 75 and dividing by the 40. So 32 times 75 divided by 40 is 60. And then I would go and plug that in Desmos, and I would check and make sure that I solved correctly. 60 over 32 is equivalent to 75 over 40. They have the same scale factor, the same ratio. You feel okay about that process? We got the steps written over here, and you can refer to what we did on these. Now, on the next one, this one's a little more complex. We're going to follow the same steps, but notice the sides are not just X or numbers. There's expressions, okay? So this is a little more complex, but we're going to go through the same steps. So let's mark what is corresponding. So T and C and L to H. And you can mark Y and K, or you can leave them blank. It doesn't matter. So that means that LY, which is what I'm looking for, would correspond to KH, and CH corresponds to TL. So there's my corresponding pieces. So now I want to set up my proportion. So when I go to set up this proportion, let's go pink to pink. So left to right, and then I would go left to right with the green. Left to right. So you get your proportion. I can solve this by hand, algebraically, by cross multiplying. But here, when you cross multiply by an expression, you need to make sure that you use parentheses, because that 10 is being multiplied by the entire 4x minus 1, not just by the 4x. Same thing this way. The 25 is being multiplied by the entire x plus 5 expression. So I end up having to distribute. So now this is an algebra problem. So that's 40x minus 10 and 25x plus 125. Some of you, when you're solving your algebra equations, you like to draw that line down the middle to separate the left and right. You can do that. And we're going to get x's to one side. So I'm going to subtract 25x over to get rid of it on the right. So that leaves me with 15x. And I've got the minus 10 still. And then over here, I've just got the 125. So then I'm going to move the constant to the right. Opposite is add 10. That gets rid of it on the left and leaves me with 15x equals 135. Then I divide out the 15. You got to divide out your coefficient. And 135 divided by 15 is 9. Now, that is algebraically how you solve that, like we did the last ones. However, when you have these more complex ones, I want to show you how you can use Desmos to your advantage. Okay, so you could come over here. Oh, well, I'll show you when you get back from lunch. Okay, I'm going to finish it for this video, but then I'll show y'all when y'all come back from lunch. Okay, so you would set up your ratio just like we have it. So 25 over 10
I put my arm
is equal to 4x minus 1 over x plus 5. Okay, and if you have this typed in correctly, if you have the correct proportions set up, you'll notice in your graph, you get a vertical line through your solution. And so you can see your solution. Now, if it's a decimal, it's not going to be as easy to see. But I can see there's 5, 6, 7, 8, 9. So that's at 9. The solution is 9. And that's what we got algebraically as well. So you can do it that way. Another way that some people, no, I'm not going to show you another way. This is the simplest way in Desmos is to just type your proportion and see the solution, the vertical line through your solution. You can do it with the more simple ones, even these on the front that we did. So for instance, like if instead of cross multiplying and dividing, if I just typed this in as x over 32 equals 75 over 40, you can see it'll give me a solution. Now I have to zoom way out because that was a big number, 60, but there it is. It's at 60. 60 was the solution. Okay, so sometimes you have to zoom way out if you're getting a larger value. But this is the one logically thinking, we knew it had to be between 32 and 64, so that's where I would go look, is in that area. So you can use Desmos and write out your proportion, and then it will give you a vertical line through the solution. So that's a strategy to use. Now, we didn't finish this problem. We found x, but that's not what the question asked for. It asked us to find Ly. So I would come over here and I would plug that x back in. So 4 times 9 minus 1. And you could also, to check that you did this correctly, that actually is accurate, you could plug it in over here as well, just to be sure. So that comes out to 14, and this comes out to 35. So I think 35 is my answer. I think that's Ly. But when I say you could check in Desmos again, here's what I mean. You could check those proportions that we said. So 25 is to 10. Okay, so that was left to right pink, and then you could do left to right green. That'd be 35 is to 14. So you can check 35 is to 14, and those did come out well. You can get that as a fraction so that you can see that they match. So those are equivalent. That means that we solved it correctly. All right, last but not least, you've got nested triangles. When you have a nested triangle, when I say nested, down here. Okay, it's one inside the other. So you've just got this extra line in V drawn, and it creates a smaller triangle, BNV, inside that larger triangle, BRG. And they tell you up here that these are similar. That's the similarity statement. Obviously, B is congruent to itself. B is a part of both triangles. And then they tell you that N corresponds to R and B corresponds to G. So I'm going to show you 2 ways to do this. Because you are told that they are similar, they tell you in this statement, that's what the symbol here means, similar. Because they are similar, I know that this line has to be parallel to this one. Okay, if they were not parallel, these wouldn't be similar triangles because then the angles wouldn't be equivalent to each other. Okay, so because they're similar, I know those are parallel, which means there's something, it's splitting these sides, the segment in B that is drawn, creating that second triangle. It splits the sides into two pieces, splits that into BN and NR, and it splits this into BV and BG. And it splits them proportionally to each other. So the easiest way to do this is when you have nested triangles, and I should say nested similar triangles. If your nested triangles are similar, the sides are split proportionally. So that means that I can set up a proportion with those corresponding pieces. Now, it's not necessarily sides of the triangle, but it's pieces. So this piece, 12 and 9, is the same proportion, the same ratio as this piece, 8 to x. So I can set up the proportion as 12 is to 9, as 8 is to x. See, I went left piece, right piece, left piece, right piece. Or I could go 12 is to 8 as 9 is to x. I could go top, bottom, as long as I'm consistent. So this is one way that I can do this. And I can only do this with nested similar triangles. That's because these are parallel to each other, that it's called like a side splitter theorem. You're splitting the sides proportionally. And then you can cross multiply and divide. Now, the other option on doing this is to split up the triangles, take this little one out of the big one to visualize them side by side. So if you took the little one and the big one and drew them side by side instead of inside of each other, for some people that helps them. The little one would be B in V, and the big one would be B, oops, R, G. And you could look at them side by side and mark those corresponding pieces. So the B is to B. N is to R. The G is to the V. Okay, so you can see what corresponds, and then you could add your labels for the side lengths they gave you. So the little triangle, this is 12 from B to N and 8 from B to V. Now in the big triangle, you would have to add these pieces, 12 plus 9. So that length is 21. Same thing in the big triangle, it's all of this together. So you'd have to do 8 plus x, which we don't know x, so I write it as an expression. And then if you did it this way, it's similar to what we just did in number 5, where we set up the proportion. So I would say, I could highlight my corresponding sides. Oops, supposed to switch colors. BN to here. As BE is to here. So when I set up my proportion, I could say 12 is to 21, as 8 is to 8 plus x. And then I could cross multiply and solve algebraically, or I could type this in Desmos and have it give me the solution for x. Okay, and I'm going to show you either one of these, you're going to get the same solution, whether you set it up side by side triangles like this, or if you do the pieces proportionally split. Okay, so if I did this one, doing 21 by 8, which is 168, then I'm doing 12 by 8 plus x, and I would have to distribute. And 12 times 8 is 96. So 96 plus 12x equals 168. And I would solve for x by subtracting the 96, moving the constant away from the variable. 168 minus 96 is 72. And then I would divide out the coefficient, 12. And I would get 6. Okay, now let me show you if you had done it that way, but used Desmos. So you would have had set up your proportion as 12 over 21 equals 8 over 8 plus x. And you can see a solution there. Look, it's at 6. Same thing we got doing it by hand. So Desmos by hand with this setup, both got 6. Doing it with the side splitter, splitting the sides proportionally and setting up that proportion, we should get the same thing, 9 times 8. And then you divide by the third number, which is the 72. So you would do 9 times 8 divided by 12. So again, you're doing 72 divided by 12. That's what we just did right here, and we got 6. So no matter which way you do this, you get x is 6. Then you go read the question. Is that what they're asking for? It says find x, the length of, and that's a typo. X is not the length of NR. NR is just 9. So let's scratch that out. X is the length of VG. So find x, the length of VG. So we found it and showed you like 2.5 different ways you could do that. Whatever you prefer. Okay. So that is finding missing sides or pieces of sides in similar figures. So there's a practice assignment 5.4 in Delta Math linked in your Canvas.